was that? Ah, nice. New intro. Hello, Chris. This is Alan. It's September 30th, and today is Science Friday. Today's video is going to come to you in two parts. Part 1, updating my realm of existence, and Part 2, Science Friday. I don't know if I've mentioned this, but I am a poet. And with that in mind, on Saturday night, I'm going to be on 91.5 FM KUNV Las Vegas for Future Experience. Future Sound. It's going to be Saturday night, midnight to 2, American West Coast time. Which means, Chris, it'll be Sunday morning, 8 a.m. to 10 a.m. I am going to do a set on the Carl Sagan of chemistry-esque material. So, tune in for that. By the way, the live stream online going to be in my pants. My radio appearance is going to be a duality with Sideshow Yoshi, which is a pretty odd pairing because he does actual, true, and good hip-hop. And I do, if you only listen to the show, I only do nerdy stuff, like true nerd stuff. Stuff that'll make Nerdfighteria proud. So, that is quite an odd pairing. It is. As far as the academics is concerned, I am kicking their ass. It's about time. Finally settled into that whole groove thing. Got that groove going on. Statics is pretty easy. It's a review of 180, which I've aced. It's only looking at it's taking one aspect from one class, blowing it up into full minute detail. Yeah, and my math classes are pretty easy. And my hazmat is the most annoying one. And it's online, but the annoyance from being online is overcompensated for by the fact that it's heavily chemistry related to a chem guy, so that's always good. Part 2, Science Friday. I'm doing explosions this week, and I am not going to be doing it with the benefit of a whiteboard this week. I do that because, well, I don't have the time to go over to the campus and utilize their whiteboards, so this will have to do. Explosives are defined by 4 characteristics. 1, they have to decompose very exothermically. Which, exothermic, you'll remember that from a couple weeks ago. 2, the products have to be in a gaseous state. Its decomposition must occur very rapidly. And 4, it must be stable, and the compound must be stable enough to explode predictably. Now I'm going to go over each one of these characteristics in detail. Characteristic 1. It has to be very exothermic. You'll recall from a couple weeks ago, I mentioned that an exothermic chemical reaction is a chemical reaction that releases energy into its surroundings. Just any exothermic reaction will not do for the definition of explosives. I mean, if you've seen C4 explode or TNT explode, napalm explode, it's not a small amount of energy released. It's a lot, a lot. So there you have it. It has to release a ton of energy. Well, not a ton, but yeah. Characteristic 2. The explosive chemical reaction must produce chemicals in the gaseous state. And when I use chemicals in the chemistry sense and not in the common sense. The common sense of the word chemical is anything that is harsh to anyone, any combination of, or all of the senses to humans. The chemical meaning of chemical in this sense is just anything that has a chemical formula, anything that is an atom or a molecule. Like, for instance, this chemistry book is filled with chemicals, none of which would be used in the common sense, but they're still made of chemicals. The paper is chemicals, the cover is chemicals, the sticker is chemicals. So, but all of these chemicals are in the solid state of matter. In the water that I am drinking right about now is just it's a chemical in the liquid state. The air that I'm breathing is just a chemical, a set of chemicals in the gaseous state. That's it. So, with that in mind, an explosive must, when it explodes, produce chemicals in the gaseous state, as in the same state as the air I'm breathing. And you'll see that every explosive you've probably heard of does this. Nitroglycerin produces nitrogen gas, carbon dioxide gas, oxygen gas in small amounts, and water vapor. The water it produces is in the vapor state. Vapor state is just gaseous state, really. The only difference by definition between a gas and a vapor is what their typical state is at room temperature. We call gaseous water vapor because, well, water is a liquid at room temperature. If it's a liquid at room temperature but is a gas when we observe it, we just call it vapor. It's still gas, but we just call it vapor. Also, TNT produces nitrogen gas, carbon dioxide, oxygen gas, and water vapor. Gasoline, when it explodes in your engine, produces carbon dioxide, water vapor, and depending on the settings of your carburetor or whether or not your carburetor is working, also produces carbon monoxide gas. So that's the second characteristic of an explosion right there. Characteristic 3. Must decompose very rapidly. This makes sense if you think about it, because check this out. Got myself a lighter here. Got myself some butane in this lighter. I spark it. there's a flame. It corresponds, it fits within the first characteristic, decomposes very exothermically. All you have to do is do that to see that, to feel it. Grab a lighter. Do that. Try to keep your hand over it for more than a second, and you're like, ah! Also, the products of me doing that are gaseous. Carbon dioxide and water vapor. But we recognize, at least I hope you recognize, that this is a flame, not an explosion. Characteristic 4. It must be stable enough to detonate predictably. Now, the wording of this is kind of iffy to me. All explosive substances detonate predictably. Everything that fits within the first 3 characteristics detonates predictably, regardless of whether or not it is stable. For example, TNT. It is stable and explodes predictably, detonates predictably. Nitroglycerin, on the other hand, is very shock sensitive, but still explodes, still detonates predictably. And by the way, don't handle nitroglycerin, especially if you're clumsy, because all you have to do is bing, bing, to make it explode. And me being able to tell you that it'll explode with that is me predictably telling you it will detonate. That's detonating predictably. So it doesn't have to be stable to predict when and how it'll explode. But then again, it also does not have to be unstable either to make that prediction. Well, that's the whole thing on explosions, at least the very bare bone basics of it. I mean, if you wanted to go into like theory and research on it, I'd probably take up a full day on that. And that's just the final project. So, I hope you learned stuff. My plan was to do a demonstration, but I don't have time for that. Don't have the legality for grabbing other people's clips either, so just gonna have to leave you with that. So on that note, I'm gonna prompt you to leave suggestions for my next Science Friday in my pants. And until next time, Chris, I will see you on Monday. DFTBA.